The chi-square test is a test, the statistical hypothesis that you find out whether the observed is significant between the expected, the differences. In this problem, we're going to observe cross 3, which is the cross between the gray long wing and an ebony short wing. When you complete the Punnett square between both, you find out that the ratio is 1 to 1 to 1 to 1, which means that there's 4 out of 16. There's a 4 out of 16 possibility for the offspring to be one of the 4 different phenotypes. When you come back to the chi-squared table, they give you the observed already of the 4 different phenotypes, and in order to find the expected, you multiply the total amount of offspring, which is 64, times 1/4. What you get is 16 for the observed. The expected. The expected goes into the table, and then you plug them into the formula to find out these numbers. You add them together, and that's what gives you the chi-squared. In order to find out whether the probability, the chi-squared is significant or not, you have to use the probability table given to you that has 4 different probability levels. You usually use 0.05 in biology. And in order to find out, you need to find the degrees of freedom, which is n minus 1, n being the amount of phenotypes or the different categories, which is 4 minus 1, which is degrees of freedom of 3. And when you go into the table and cross the 3 with the 0.05, you find out that the probability of 7.82 is greater than 1.25, which makes the difference between the observed and expected not significant.